Hi, I'm Benny D, and in this video we're going to look at function notation. So in our previous work we've seen different functions that have different identities. So for example, we've got log to the base e of x plus log to the base e of y equals log to the base e of xy. And we can actually write this in function notation, because we can call this function here f of x. Okay, and we could call this function here f of y. And we could say that this last function is f of xy. Okay, so I'll replace my x with a y in this one, that's why it's become f of y, replace my x with xy in this one, which is why it's become f of xy. So we've got this nice little equation here just using function notation. Similarly, with this example here, we could say that e dx is f of x times e to the y, which we can say is f of y, and that's going to equal f of x plus y, okay, from that index law. Okay, so what we can do is actually, we can see a range of different types of question that utilize this function notation. We'll have a look at a couple of examples here now. Okay, so our first example that we're going to look at is looking at the rule f of x equals 2x. Okay, and we want to show that f of x plus y equals f of x plus f of y. Now the easiest way to go about this is setting it up with left hand side and right hand side for your equations. Okay, and just setting up both of them, manipulating one or the other or both, okay, until you get things that are equal or not equal depending on what the question is actually asking. So f of x plus y for our left hand side, that means that we're going to have 2 times x plus y. Okay, we'll leave that at the moment. F of x plus y means we're going to get 2x plus 2y. Okay, just subbing in our x and our y into our function there. When we factorise this though, we get 2 outside of x plus y, and we can say therefore left hand side equals right hand side as required. Okay. And it's as simple as that for some of these. Okay, we'll have a look at some other examples though, some do get a bit harder as well. So our next one that we're going to look at, okay, is we've got a function f of x equals x plus 2, and we want to show that f of x plus y does not equal f of x plus f of y. Okay, so again we're going to set up our left hand side and our right hand side. Okay, our left hand side is going to be, we've got an x, we're going to put an x plus y, so we've got an x plus y plus 2 for our left hand side. For our right hand side, we're going to have x plus 2 plus y plus 2, which we can say is x plus y plus 4. So we can say, well, therefore, our left hand side does not equal, okay, our right hand side. Since our right hand side has plus 4 and our left hand side has plus 2, okay, as required. Okay, we're going to have a look at one more example here, okay, which is we have a function f of x equals 1 on x, okay, and then we want to verify that f of x plus f of y equals x plus y times f of xy. Okay, so notice now we don't just have straight functions, we've actually got this other term out the front. Okay, and this could be including our variables x and y like we've got here, or it could be a number, it could just be f of x plus f of y equals 3 times f of x, y. Okay, so it doesn't matter too much, we still approach this the same way. So left hand side, right hand side, okay, and just start putting things in. So left hand side we're going to get 1 on x plus 1 on y. Okay, our right hand side is going to be x plus y times by 1 on xy. Okay, I'm going to start by manipulating this because it's multiplying through, so I can just say I've got x plus y over xy. And for this one though, you can see we've got two fractions here. I've got to get one fraction here so I can compare them. Okay, so we need to make our denominators the same. So we're going to do that by doing our cross multiplication. Okay, so we're going to multiply this fraction by y on y to give me y on xy. and this fraction by x on x to give me x on xy. Add these together and put my x first. I'm going to get x plus y over xy. Okay, and then we can say therefore our left hand side equals our right hand side as required. Okay, so when are you most likely to see these questions? The most common time you're going to see these questions is on exam 2, okay, in the multiple choice section. And what they'll often do is give you a situation like this, okay, where they say, hey, okay, you got f of x plus f of y equals x plus y times f of xy, and you're actually finding which function satisfies this, or which function doesn't satisfy this. So each of your responses, A, B, C, D, E, okay, will give you a different type of function, okay, and you're seeing which one works. Okay, or you could be given one where you've got this function and each of your multiple choice answers is a different equation like this, and you're seeing which one is true for that given function. For these questions, often it's a little bit challenging, okay, to see straight away which one might work, might not work. Okay, so my hot tip there is, if we've got to go through and work on them all, okay, start at the bottom. Okay, start at the bottom and work your way up, because most of the time the answer will either be C, D, or E. Okay, so just to save yourself a bit of time, a little hot tip there, start at the bottom, work your way up on any multiple choice question where you're kind of going to do the number crunching and going through and trying all the options. Okay, you can set this up on your calculator, so you can define f of x, you can define f of y, okay, set up this equation and see if it's true or not, okay, is another way of going about this as well that can save you a bit of time too. Okay, so look, hopefully that's enough to get you through this section and the questions on it.